How to calculate weight from mass. The weight of an object is the force of gravity exerted on that object. The mass of an object is the amount of matter it has, and it stays the same wherever you are, regardless of gravity. That's why an object that has 20 kilograms of mass on Earth also has 20 kilograms of mass while on the Moon, even though it would only weigh 1/6 as much. It weighs 1/6 as much on the Moon because the force of gravity on the Moon is 1/6 of what it is on Earth. Read on for information about and tips on calculating weight from mass. Part 1, Calculating the weight. Step 1, use the formula W equals mxg to convert weight into mass. Weight is defined as the force of gravity on an object. Scientists put that sentence into an equation by writing W equals mxg, or W equals mxg. Since weight is a force, scientists also write the equation as F equals mxg. F equals symbol for weight, measured in newtons, N. M equals symbol for mass, measured in kilograms, or kg. G equals symbol for gravitational acceleration, expressed as m/s2, or meters per second squared. If you're using meters, the gravitational acceleration at the Earth's surface is 9.8 meters/s2. This is the standard international unit, and the one you should probably be using. If you're using feet because you have to, the gravitation acceleration is 32.2 f/s2. This is the same unit, it's just rearranged to reflect feet instead of meters. Step 2, figure out the mass of an object. Because we're trying to get weight from mass, we know we already have mass. Mass is the fundamental amount of matter an object has, and is expressed in kilograms. Step 3, figure out the gravitational acceleration. In other words, figure out g. On the surface of the Earth, g is 9.8 meters/s2. Elsewhere in the universe, the acceleration of gravity changes. Your teacher should tell you, or the problem should indicate, where the gravity is acting from so that you know. The gravitational acceleration on the Moon is different from the gravitational acceleration on the Earth. Acceleration due to gravity on the Moon is about 1.622 meters/s2, or about 1/6 of the acceleration that it is here on Earth. That's why you weigh 1/6 of your Earth weight on the Moon. The gravitational acceleration on the Sun is different from the gravitational acceleration on the Earth and Moon. Acceleration due to gravity on the Sun is about 274.0 meters/s2, or about 28 times the acceleration that it is here on Earth. That's why you would weigh 28 times your Earth weight on the Sun, if you could survive.
Step 4, plug the numbers into the equation. Now that you've got m and g, you'll be able to plug those values into the equation F equals mxg and be ready to go. You should get a number described in terms of newtons, or N.